All right, so we've moved on to section 2.6. So we are going to be working on more graphing techniques for linear equations. So what we're going to do is start with our first objective here, which is we are going to graph linear equations using intercepts. So we're going to talk about your x and y intercepts. So we've already talked a little bit about a y-intercept, or you're probably familiar with it anyways from doing y equals mx plus b, or your slope formula, or your not slope formula, so your linear equation formula. So to the left is the graph of your function fx equals 1/2 x minus 4. So the graph of the function intersects the y-axis at 0, -4, and intercepts the x-axis at 8, 0. All right, so let's make a few points here. So as a reminder, this one here is where I cross the x-axis. So that is my x-intercept. So if you notice, this happens where y, if we look at the y-axis, where y is equal to 0. So sometimes your x-axis is referred to as just this line here, which is going to be a line where y just equals 0. So you're going to see a little bit more of that here in a bit. This one here we said was your y-intercept. So here where your y-intercept is, this is where if you look at x, if you could look at the x-axis, it's where the x-axis we cross over at 0. So this line, your y-axis, is x equals 0. So let me write this back in here one more time. We said that y-intercept, because I kind of covered it up, was 0, -4. So your x-coordinate is 0. Just like that line there is your y-axis as x equals 0. So when you're looking for your y-intercept, that's when x's are 0. If we look at our x-intercept, let me write that point here again, a little bigger. That was 8, 0. So your y-coordinate is the 0. Your x-axis is going to be the line y equals 0. So if you want your x-intercept, that is when y is equal to 0. So as I said here, you notice that your x-intercept occurs when y equals 0, and your y-intercept occurs when x equals 0. So to kind of put this all together here in a little bit, if we are looking algebraically for your x and y intercepts, we now have a technique to do that. So if you remember, our original function was fx equals 1/2 of x minus 4. So here, when x is equal to 0, so remember, we're just placing all our x's with 0 here, using that function notation. If you remember, this part is basically your y. If we do that, we're going to just be left with, this is going to cancel out, f of 0 is just -4, which we know f of 0 is just y. So you're going to get your y-intercept. Like I said, x equals 0, y-intercept. Let me use blue so we can see this one a little differently. So if I am looking when my y's are equal to 0, so if I set y equal to 0, that's equivalent of just saying fx is equal to 0. So I'm just replacing this whole part with 0. 0 equals 1/2 x minus 4. 4 equals 1/2 x. We keep going and solve that, we get x is equal to 8. So here we go, we get another ordered pair of 8, 0, which is your x-intercept. So algebraically, if we want to find your x and y intercepts, we find a y-intercept by setting x to 0. We find an x-intercept by setting y to 0. So I know that's a lot to take in verbally. That's why we have this slide. If you want your y-intercept, a y-intercept is going to be, and this applies to any function, a y-intercept is a point 0b. So the x-coordinate is 0. If we want to find what b is, that means we have to let x equal 0, and then we just solve for y. And x-intercept is going to be a point a0, so your y-coordinate is the 0. To find a, we need to let y equal 0 and solve for x. So that's what we're going to do here. So we want to find the intercepts of this line that we have up here. So let me get some nice red out so we can see. So we got 5x plus 2y equals 10. So this is a function. Don't worry about that part yet. But this is going to be a linear equation. So what we're going to do, we want to find those intercepts. That was the first task that we were given. So your x-intercept, if you remember, that occurs when you set your y equal to 0. Your y-intercept occurs when you set x equal to 0. So for my first one here, I'm just going to have y0. So I'm going to still keep 5x plus 2 instead of y. It's going to be 2 times 0 equals 10. Well, that's going to give me 0 there. So it's just going to leave me with 5x equals 10. Divide both sides by 5. So we get that x. And we get that x is equal to 2. So our x-intercept is going to be an ordered pair where x is 2 and y is 0. So x is 2 and y is 0. I'm just going to write the point here again. If I want my y-intercept, well, here, like I said, I just want x 0. So I'm going to have 5 times 0 plus 2y, because I don't know what y is, equals 10. So once again, I'm going to get a 0 here, but I'm going to be left with the 2y equals 10. Divide both sides by 2. And we get y is equal to 5. So we get the ordered pair 5. Oops, did that backwards. We get the ordered pair x is 0, y is 5. So 1, 2, 3, 4, 5. And now all we needed to graph a linear equation was just 2 points. We have 2 points. The question is, am I going to get this through? Oh, I did it right the first time. And there we go. Now we have the graph for our equation. So that's the graph of your line. All right, I'll give you a second here. So this is a technique that we can use in not every case of a linear equation can we do this, but very often, especially when we have something of a general, like in a general form like this 5x plus 2y equals 10. A lot of times finding those x and y intercepts are the easiest points to look for first. So sometimes we use this just because x and y intercepts are easy to find. Another thing is that x and y intercepts are important in certain kinds of problems. If you're looking at finance, sometimes you want to know when things bottom out. So when does y hit 0 and things like that. I think there's an optics problem that uses this too, but there are certain cases where it is necessary to know what those intercepts are. There's a lot of important information at those intercepts. Get you through your solution here. But as I was saying, since we only need 2 points to graph a linear function, we can use x and y intercepts as those 2 points. So I'm going to make a little correction here. No, not all graphs of linear functions, equations, because there is a linear equation that is not a function. Not all linear equations will, just taught that, will have x and y intercepts or distinct intercepts. So we'll see later that we're going to have vertical and horizontal lines. those will only intercept either the x-axis or the y-axis. They will not intercept both, unless they happen to like be an axis. The other one is that we might not always have distinct intercepts, meaning that your x and y intercept couldn't be the same intercept. That happens in the case when you cross through the origin. So if you cross through the origin is going to be your x and your y intercept. We'll have some examples of that later. But at this time, if you could take a moment and pause this video, we have this problem for you. So you'll have problem 9 and problem 10. So both of them, if you could take a moment, try to find their x and y intercepts and then graph the equation. And then come back here and we'll see if you got the solution correct. So hopefully you were able to take a minute and do this. So once again, looking for x and y intercept. X intercept is when y equals 0. So we're going to have 0 equals 1/3 x plus 1. So I know we reviewed this not too long ago, but we'll go through it again. I want to solve for x, so I'm going to first subtract 1 from both sides. So I get -1. I need to leave a little room here. -1 is going to be equal to 1/3 x. If I want to deal with this 1/3 here, I can multiply by 3, which means I have to multiply by 3 here, which means I'm going to have -3 equals x, which I know a lot of you don't like it that way. So remember, you can just flip it. Y is equal to -3. So my x-intercept is going to be -3 equals 0. And also you can always look at this number and plug it back in here and see if it works. So x equals -3, put it in here, I get -1 plus 1, get 0. My y-intercept is going to be when x is 0, so y is equal to 1/3 times 0. This one's going to be a lot of work for us. So this goes away because that's multiplied by 0, y equals 1. Oh, that was hard. So here we see that x is going to be 0 and y is going to be 1. So this is my x-intercept. So remember that was x is -3, y is 0. This is where x is 0 and y is 1. So I got my two intercepts. And we'll draw a line right through it. Number 10, if you still didn't do it, you can pause and work on it here. But I'm going to start working on it right now. So here, once again, y is 0. We're going to not write as much on here. So we know that y is going to be 0. So I have to subtract 4. So I'm going to get -4 equals -3/4 x. Multiply both sides. So remember, because this is a 3/4, we're going to multiply by a -4/3. Didn't leave enough room over here on this side. But over here, we're going to have -4 times -4/3. So just as a reminder, what I gave you was this. But this should be x over here. So you're multiplying your fractions. You should end up with 16/3 equals x. Or in our case, we're going to say x is going to be 16/3 and y is going to be 0. So we'll talk about that intercept here in a second, but let's do y. So for y, that's just where x is equal to 0. So once again, the really hard one. All right, so we got that 0 in. That 0 is going to cancel out everything. Well, not everything, the negative 3/4. So we're just left with 4 there, y equals 4. Okay. I'm being kidding. It's not the hard one. X is 0, y is 4. So this one, that's going to be easy for me to graph. There's my y-intercept. This one, 16/3, not quite as easy. So this is kind of where using intercepts might fall apart on you if your purpose is to graph. Like I said, there may be cases where you may need to know your x and y intercepts for other problems, especially in the future of this course. But as far as graphing goes, that's a little hard one to deal with. So 16/3 is the equivalent of 5 1/3. So we're trying to figure out, it'd be somewhere out here. It doesn't quite fit in here, but 5 1/3 is somewhere out there. But like I said, trying to fit things like thirds in here, it can be a little difficult. You know how to eyeball them, but you can have much more nastier fractions than this that you're trying to graph, or even something that doesn't even give you a nice clean fraction. So there are places where this technique kind of falls apart. As we mentioned before, sometimes you might not have 2 intercepts, or in this case, you might just have one that's kind of an ugly intercept. You can still use this technique, just might not be the best one. All right, so we are going to stop here. And then our next section, we're going to talk about your vertical and horizontal lines and your ones where you intercept the y at the origin.